it's Oisín here from New Music Technology. Today I'm going to show you how HRF can help improve the perceived clarity, the punch, cohesion and dynamic articulation of a mix through harmonic organisation and masking reduction. So here we have a like an indie rock track recording here. You can see it looks quite compressed and almost dynamic range, that classic kind of brick-like waveform. So we'll play it through Melda's loudness analyzer here. It's a useful tool that helps measure the sort of like loudness and dynamics of the track. It will pay particular attention to the PLR, which is the peak to loudness ratio. It's a comparison of the true peak, which is the highest actual waveform peak, compared to integrated LUFS, which is the sort of perceived loudness measured across the whole track, averaged out. And we'll also have a look at the dynamic range measurement to see how the range dynamics play out. So I'll just play the track here first, and also keep an eye on this meter here. May be able to see that there's too much movement in the peak meter. So we just played the track through the loudness meter, and you'll notice that the PLR value is 12.1. We'll compare it to the HRF version afterwards, and the range is quite narrow there, 2.8 loudness units. So I'll just introduce to HRF now. So for the HRF settings, I found that the best results came from a moderately high optimizer amount with more restrained dry wet. The optimizer improves harmonic organisation and reduces masking between overlapping elements, while the dry wet determines how much of the processed harmonic structure is blended back in with the original signal. I've also focused the processing more towards the upper bass and low mid regions, using the output filter with complement mix to reintroduce the bass that could be lost with filtering. In this case, I helped these settings help the bass feel cleaner, larger, more spacious, while without over controlling the sub fundamentals, preserving the natural low end weight of the track. So I'll play the track now with HRF applied. that the PLR value, that's the peak to loudness ratio, it's increased this time up to 13. And the range is also quite wider as well. So there's an increase in dynamic range. This could be caused by the harmonic filtering in HRF. So filters turn up more of the most frequently found tones and turn down more the less frequently found tones. And you can see this in the spectrum analyzer. These are the positions of the 120 tonal filters. They're color coded, matching the chromatic tones in the filters below. So you might be able to see how they turn up the ones that are more frequently found. So I happen to clear out the kind of relatively harmonic sounds and noise. So you may be able to hear it better once I play it through again here, and I'll A/B the track using the bypass button. Quite clearly there's a bit more movement in the level meter whenever HRF was applied, and that's the range of dynamics in action here. So that's my demonstration of HRF in the sense of helping to correct overcompression in tracks. Hope you find this video quite useful, and hopefully you enjoy using HRF. Thank you, and I'll see you in the next video.